Hello, I'm Colin Daly of Campbell Scientific in Logan, Utah. In this video, we'll take a look at using array notation, repetitions, and aliases in your CRBasic programming. This is particularly useful when you have several or many of the same type of measurements. In today's example, I have two temperature measurements. I could declare the variables for these measurements as air temp 1 and air temp 2. But if I had 100, we need a better way. Using array notation is that better way. Here we declare a variable with a base name and in parentheses indicate how many elements we need. 2 in my example. We can refer to these individually as air temp 1 and air temp 2. Now let's take a look at our measurement instruction. I'm using thermocouples. By setting up our instruction with an array for the destination and repetitions, we can use a single instruction to measure a series of sensors. This is important. When using more than one repetition for measurement or output instructions, you have to use array notation for the variables used by those instructions. In the destination variable, I've selected our variable array. Notice that it is inserted with empty parentheses. When there's nothing in the parentheses, that means we start with 1. Since our variable has been declared as an array, we can use repetitions in the instruction. Here it is set to 2. We have two thermocouples of the same type. The diff channel parameter indicates which channel the first thermocouple is in, channel 1. Because we are using repetitions, the data logger knows the next sensor will be on the next sequential channel, which is number 2. By using 2 repetitions, the data logger knows to take measurements on channels 1 and 2 and write those values to variables air temp 1 and air temp 2. You can also use repetitions with variables declared as arrays in output instructions. Again, we're using 2 repetitions and reading from our variable array. This is the same as having 2 separate average instructions. The first outputting an average of air temp 1 and the second outputting an average of air temp 2. We are not averaging the 2 measurements together. There is a different instruction if you want to do that. It is called spatial average. Now compile and save. No compile errors or warnings. Watch our other tutorial on common programming errors and how to fix them for information on the variable out of bounds error that can happen when using array notation and repetitions. We'll go to the connect screen to send our program to the data logger. It is a good idea to connect and collect the data before doing anything else. We'll send our program using array notation. The warning reminds me that the data logger will delete its stored data when it gets the new program. I'm okay with that since I just collected it. Now let's take a look at our data. First, the public table where we see our variable array, air temp 1 and air temp 2. This is the line in our CRBasic program where we set that up. Next, we'll look at our stored data in the table called test. The resulting field names are air temp underscore AVG1 and air temp underscore AVG2. This is the line in our CRBasic program where we set that up. Now let's collect data and take a look at it in ViewPro. There's our data file. Notice the column headings or field names, air temp underscore AVG1 and air temp underscore AVG2. Now let's go back into CRBasic and see how using the alias declaration can help when using arrays. Type the word alias or insert it from the instruction panel. The syntax is variable name equals alias name, so we need to insert our variable name. Here, using function key 9 saves you from having to type it out and potentially make a typo. Watch our CRBasic features tutorial for more information on using F9, F10, and other handy editor tricks. Air temp is inserted with empty parentheses, so we'll edit that and assign it an alias name, top temp in this case. Using the same technique, we'll call air temp 2 bottom temp because I have one thermocouple on top and one on the bottom of whatever I'm monitoring. That's the only change we'll make. No errors, messages, or warnings. Collect our data because that's a good habit. Send our revised program. Now let's take a look at our tables and see how using aliases affected them. First, the public table, where we see our alias variable array, top temp and bottom temp. And these are the lines in our CRBasic program where we set that up. Now we'll look at our stored data table. Here we see the alias names _avg. When we collect and view the data, we can see the same alias field names in the column headings. Top temp _avg and bottom temp _avg. Remember, when using repetitions for measurement or output instructions, you have to use array notation when declaring the variables used by those instructions. Using the alias declaration makes viewing your data easier by assigning unique names to the variables and therefore field names. Please contact a Campbell Scientific Application Engineer to discuss your application and for answers about using array notation and aliases in your CRBasic programs.